Good morning, class. My name is Len Chamberlain, and this is my third presentation for Professor Green's ISA 4220 System Security course. This presentation is over POP3 and SMTP. In this presentation, we will be discussing the listed services, which are POP3, Post Office Protocol 3, and SMTP, or Simple Mail Transfer Protocol. For each, we will have an in-depth discussion on the technical aspects of these services, as well as discussing the known best practices, as well as how to implement them. POP3 does very much what the acronym sounds like it would do. Post Office Protocol 3 is utilized in the delivery of email from the mail server to a mail client and is the third version of this widely utilized protocol. It handles messages, downloads, and the requests made to Windows email servers, which will be discussed shortly. POP3 and its predecessors date back to the very beginning of email, with POP being created in 1984 and POP2 being developed shortly thereafter in 1985, and POP3 shortly thereafter that in 1998, which means it has been running for nearly 30 years as it is. POP3 is currently one of the most common email protocols, and POP4 has been proposed, but not much effort has been made to move, as POP3 currently serves as a reliable protocol. The POP protocol was developed in a different era of the Internet, one in which computers were not constantly connected to the Internet. When computers did connect to the Internet, POP would allow the email clients to pull all the emails that are stored on the server to the user's local machine, all the emails since the last time the user logged in, and then delete the copies from the server usually. This was and is a useful means of email distribution when there's only one device checking, sorting, deleting, and sending messages. Options within Outlook, such as leave a copy of messages on the server within account settings, will leave the messages on the server when they are downloaded to the client, but each device that downloads them will interact with them separately. If this option is not enabled for email accounts utilizing POP3, then no other email clients will be able to download the emails downloaded after the first client downloads the mail. For example, if a user deletes or sends an email on their laptop, those emails will only show in their sent and deleted folders on that machine. If they log into another laptop or their desktop, it will be independent from the changes made on the original laptop. This can create confusion and generally not an efficient manner of managing emails on multiple devices. Even with those limitations, POP3 is still an extremely reliable protocol for email distribution. POP3 is an application layer protocol that listens on port 110 to authenticate users and to manage their connections to the server. This is a very simple protocol, and the commands needed to communicate with the POP3 service, while the email client usually handles this, are also very simple, handles them for you. If so desired, a user could connect via telnet to port 110 and manage email utilizing these commands. The commands are presented in a series of states, and that service tracks them. The first state is the authorization state, in which the user must confirm their identity and authorization through presenting their username and password. POP3 can utilize Active Directory, local Windows accounts, or other encrypted password files as an authentication database. Active Directory may only be used if the mail server is part of the domain and Active Directory is running on the domain controller. The local Windows account option is utilized when the mail server is not a member of Active Directory domain and the user accounts are simply created as local accounts on the server, which I don't recommend. The encrypted password file authentication is a choice necessary when the server is not in the domain and there are no accounts locally on the server. In this situation, a hash of the password is created using MD5. When the client authenticates with the mail server, it will send a hash of the user's password to the server, which then compares it to the hash saved in the mailbox lock file that was generated previously using the MD5 hash. Regardless of the authentication database is utilized, the client will need to send the user and the password to gain authorization. Once authorized, the session then becomes the transaction state. The transaction state is where the messages are able to be displayed, downloaded, and marked for deletion. The mail client will send the command stat, which will return the number of messages in the user's mailbox along with the size and bytes for each. To retrieve the message from the server and pull it to the client, the RETR return command is used. This command will also mark the message for deletion unless the mail client has a previously discussed option enabled to leave the mail on the server. There are various other commands within the session to interact with the mail contained on the mailboxes as well. The update state is used to terminate the session with the service and contains the quit command. This command will return the greeting message as well as cause any messages marked for deletion from the previous session, the transaction state, to be deleted. There are other protocols used to send email, but none are as widely and widespread as accepted as SMTP. SMTP, or Simple Mail Transfer Protocol, is generally operated over TCP port 25. It is utilized in sending and receiving email, but is generally used in conjunction with other protocols such as POP3 or IMAP. Common practice is for SMTP to be used when sending email and either POP3 or IMAP for retrieving email from a mail server. SMTP, like POP, is a very simple and robust protocol. The process by which SMTP works can be seen and demonstrated in the same way as well, through the use of Telnet. In fact, Telnet is a way in which administrators in the early days of the Internet frequently troubleshot mail flow. Using the Telnet command followed by the mail server's address and the SMTP port 25, the user can utilize the same commands and operate the same way as if they were an SMTP peer. So the telnet space mail.yourdomain.com space port 25 will allow you to connect to that SMTP peer. In this way, the commands utilized by the mail servers and clients to transfer email can be seen. When being connected, the same type of 3-digit codes utilized by the HTTP protocol we discussed last week show the connection status, indicating success or failure will be shown. So that's where the 200 series, the 300, and 100 I discussed last week come into play. Once connected to the SMTP server, the first command is the EHLO, or it's pretty similar to the hello command. There's some difference there, but it's used to identify the server that's initiating the connection. After the identity of the server has been established, the sender's email address must be presented and will be in the header of the email. All this information that we're going to be covering is actually going to be in the header. That looks like mail from is the command, colon, and then the sender's email address. And the email address must be valid and come from a valid domain or it'll be rejected. Next command is for the recipient's email and will be sent it as receipt2 or RCPT space 2 colon. And then you're going to put their email address. Well, the server will. Only one email address will be permitted at a time, but the command may be repeated as many times as necessary to fulfill all the recipient's email addresses for that email. Once all recipient's email addresses have been entered, then the simple command data will be entered, which should be returned by the receiving server with a message stating 354 enter mail and with a period on a line by itself. This states that the receiving server is ready to receive the body of the email, and once all data has been transferred, use a single period on a new line to state that it's the end of the message. After terminating the message with a period, the receiving server will respond with 250-200 message accepted for delivery, and the email will be on its way to the receiving server. The sending server can then begin a new email by simply starting with the mail from command, or it can send the quit command to terminate the session. Obviously, use the mail from command if that was going to be the same receiving server you had to send a new email to, quit command if you have to move over to another one. There are other commands that could be used, but the ones just discussed are the minimum that are necessary for SMTP peers to transfer emails over TCP port 25. There are a few very simple hardening recommendations for use within mail protocols such as SMTP. You can require TLS encryption. You do this by, on the mail server, there are options that determine the authentication required to send emails from the server. These options are located within the Properties dialog box within IIS Manager. So you go to the Manager and then right-click SMTP Server, go to Properties, Access, and then Authentication. If basic authentication is selected in this area, ensure that TLS is also enabled because the usernames and passwords for authentication would otherwise be sent via plain text, which isn't good for obvious reasons. Requiring all users to utilize TLS to connect to the SMTP server can be done after installing a certificate, as we also discussed last week in the HTTPS presentation, from a verified certificate authority, or CA. A few examples of CAs, I didn't go over those last week, but those could be GoDaddy, DigiCert, GlobalSign, Symantec. There's dozens of them, and they're for-profit. They just sell you certificates, and they're under strict regulations on who gets them, and it's basically the backbone of the internet is that trust relationship with certificate authorities. If you don't know about them, you should read up on them. They're pretty fascinating, the trust that the technical community puts on them. But once the certificate is installed, navigate to the IIS Manager. Again, right-click SMTP Server, Properties, Access, Secure Communication, and then Require TLS Communication. So that'll prevent you from transmitting usernames and passwords over clear text. Another basic step you can take to secure SMTP is to restrict access on who can access your server. So you can do that based on location. This location could be derived from IP addresses, domain names, or network IDs. It's in the same location as the authentication and secure communications was accessed in the connection control section that allows an administrator to implement a whitelist or blacklist system. These options are only the list below and all except the list below. To incorporate a blacklist, select all except the list below and input the IP addresses or fully qualified domain names of the location not permitted to access that server. To incorporate a whitelist, select only the list below and input the IP address or domain names of those that are not permitted or that are permitted. That's how you set up that whitelist or blacklist. I like to correlate options into whitelist or blacklist because it's used a lot on firewalls and other systems. And there's many other methods that you can use to secure your system, and you should. This is just a very brief introduction on what you can do. I recommend doing a further deep dive, especially for standing up our servers. And yeah, I hope you enjoyed my presentation, and I look forward to reading and hearing everyone else's. Thank you.